All right, I just want to review quickly for your homework, commutative and associative, and then distributive. These are really important concepts to know, to understand. Commutative, let's talk about that. We can have a commutative addition, commutative multiplication, just like with associative, it's with addition and multiplication. So commutative and associative, I think, are the most basic to understand. So like this would be 5 plus 2 equals 2 plus 5. Doesn't matter what order they're in, they're going to equal the same. In this case, it's 7 equals 7. Now I could change one thing with a variable equals 2 plus 5. By looking at this, I can see based on the commutative property, without having to do any computation, I have a 5 over here and I have a 5 over here, and then it's adding a 2, and this one's adding something. I know this has to be a 2. Okay? I could also do some computation to get that, but based on commutative principle, that's going to be a 2. Okay? Same thing with multiplication. 5 times 3 equals 3 times 5. Doesn't matter what order they're in. And then if I would have y times 3 equals 3 times 5, I know that I have a 3 in here and a 3 in here. Oops. That should have been times. It has to be the same. Okay? I know I have a 3 and a 3 over here. This is times 5, so this one has to also be times 5. So it can help me to solve what the variable is just by kind of looking at it, understanding the idea of commutative principle, the law. Okay, and on our sheet, the order in which you add or multiply numbers does not change the sum or the product. So it doesn't matter the order you do it in. Okay, let's go to associative. So this is saying 2 plus 3 plus 4 equals 2 plus 3 plus 4. And I'm going to group these together first, and then I'm going to group those together on that side. What this says is it doesn't matter how the groupings are. If it's all addition, you're going to get the same answer. Okay, it doesn't matter which you do first. In this case, I could do 6 plus 4 equals 2 plus 7. And this is going to be, wait a minute, you got to add correctly. 5. So 5 plus 4 is 9, 2 plus 7 is 9, equals. See, it doesn't matter which one you do first, you're going to get the same answer. Okay. I could change one of these for a variable. 2 plus y plus 4 equals 2 plus 3 plus 4. And here I can kind of figure out my variable pretty quick without doing any real computation. I know I have a 2 here and a 2 here. I see I have a 4 here, 4 here. It's all addition. This y is what I don't know. And I haven't connected it with this 3, so I know that y is going to be 3. Okay? Same thing with multiplication. Doesn't matter what you group, the order in which you group, it's not going to change the product. So 2 times 3 is 6 times 4, going to equal, this is 12, 12 times 2. Because 6 times 4 is 24, and 2 times 12 is 24. So it doesn't matter how they're grouped. You can do this first, you can do this first, but they're in the same order. So based on association, the associative principle property, they're going to get you the same answer. And just like I did before, say one of these is now a variable. 2 times 3 times p equals 2 times 3 times 4. Well, I know I have 2 and a 2, a 3 and a 3. I'm timesing it all by 4, so this p must equal 4. Okay? Based on associative principle. All right. Hopefully those are a little bit easier to understand. The more difficult one, and the one that's really, really important, is the distributive property. distributive. This is where you distribute things. You take a little what you have and you distribute it in the problem. So, for example, if I have 2 times 4 plus 5, I could distribute this out because it's going to be 2 times 4 and 2 times 5, and then I add them together. So I could go 2 times 4, because that's this here, but then I also have this here, adding 2 times 5. Okay? So I'm doing 2 times all of this. Instead of adding this first and then timesing it by 2, I'm just separating it out. 2 times this and 2 times this. With this kind of a problem, it doesn't need to happen, but when you get into variables within here, this is an important concept to understand. So let's do this. I'm going to do 4 plus 5 is 9. 9 times 2 is 18. Here I have 4 times 2 is 8, plus 2 times 5 is 10, gets me 18. Those are equal. So I distributed it over here, and it got me the right thing. Okay. Let me show you one with a variable, okay? Because you can multiply a number and a number that's connected with a variable. So for example, 3 times 4p. 3 times 4p is going to give me 12p. And the reason why you can do that is because this is the same as 3 times 4 times p. And remember, we just talked about that associative principle. Doesn't matter what order they're in, you're going to times them all together to get the same thing. So 4 times 3 is 12, times p is 12p. Okay? Now, when it comes to adding and subtracting, it's not going to be the same situation. Okay? You can't. So if this was adding, that would not equal 7p. You cannot do that because you have adding here and multiplying here. You don't just put adding and multiplying all together. You can't do that. And adding and subtracting, you have to do like terms. So if you have 4 p's here, you have to have some number of p's here to make those like terms. But with multiplication, you can, because it's all multiplication. Remember I told you when a number is touching a variable like this, it stands for multiplication. So, what if I do this? 3 times 2p plus 8. Okay? I can distribute this out, which I like to do. So I'm going to have one problem here, 3 times 2p, and then I have another problem right here. And I'm going to add these two. Okay, so I'm adding, my other multiplication problem is 3 times 8. 3 times 8. Okay? Now, 3 times 2, kind of the same as 3 times 2 times p. So this is going to get me 6p plus 3 times 8 is 24. Now, I'm adding. I have 6 p's here, I have no p's here. They're not like terms. Here's my answer. I could have, without distributing it out, I could have done this. 3 times 2p is 6p plus 3 times 8 is 24. And I get the exact same thing. Okay? We're going to practice this more. I just want to keep planting this idea in your mind. I want you to be exposed to this as much as possible and get the idea how when you have something like this, this is going to be times this, and this is going to be times this, and then you add them together. Okay? It's kind of like this is going to both of them, and then you're adding them. It's a little tricky. It will come through practice, and the more you see it, the more we do it, you'll get to a point where you just say, oh yeah, when this is like this, you just times that to there, times that to that, you add it up, you get 6p plus 24. Okay?